Okay, we are here with an episode of Agriculture Now. Now, this is a bit of a different setup for me because we've been doing Mining Now episodes at Mine Expo, but the company that we are featuring, Hardox, does a ton of work in agriculture space. So we had Jimmy Allen here. You're the technical development manager for Hardox. So it made sense to do, we're here in person. Why do it remote? Let's just do an agriculture episode right here at Mine Expo. So
that sounds good.
Yeah. Let's just do it quick for anybody who doesn't know who Hardox is.
Okay, well, Hardox is what we like to say is the supreme wear steel in the world. I mean, we try to make sure that Hardox is the ultimate, the highest quality wear steel that is produced, the number one wear steel brand in the world.
And what's the setup? There's SSAB is the parent company or like the parent brand?
Correct. SSAB is basically stands for Swedish Steel Incorporated, so it is the steel company, and Hardox is our leading brand.
Okay. I want to jump right into it because I don't want to make assumptions because other people would have seen the mining episode, but it's a completely different audience a lot of time. So I think from my understanding, we're going to focus in on two types of steel today, right?
That's correct.
Okay, what are those steels?
That would be Hardox steel and strength steel. Both of them are branded steels. So Hardox is our branded wear steel, and Strengths is our branded structural steel.
At a basic level, what's the difference between the two?
Well, Hardox being a wear steel is generally governed by hardness, where structural steel is governed more by things like yield, tensile strength, elongation, and Sharpie impact toughness.
Can you explain those three things? Because I hear that terminology. I actually have never had someone explain, and you're the person that knows what they actually mean.
Well, yield and tensile strength gives you the strength of the material, and that's generally, when structural engineers are talking about a piece of structural equipment, they're looking at the yield and tensile strength of that steel in order to determine what types of steel and then the thickness of steel to use in that application.
Yeah.
And then, of course, the elongation basically tells you how much the material will stretch from beginning until ultimate failure. And so a lot of people like to see a little bit higher elongation because they tend to tie that to the ductility of the steel.
So, sorry, can you actually clarify, what do you mean by ductility? Like bendability?
Some people equate ductility to bendability, but in other words, they're able to form it better.
Oh, I see. Okay. So in agriculture, you've got a mixture of both, right? Because there's a lot of structural, obviously steel, but then you've got, like in mining, we really focused on the Hardox.
Right.
But you've got a mixture of Hardox and the strength. How do you say it? Strengths?
Yep.
Yeah.
Strengths.
Yeah.
Some people call it Strenex, but it's strengths.
Oh, okay.
So almost like strength, but strengths.
Okay, got it. What's sort of the setup in the agriculture world for the two?
Well, in the agricultural world, they generally like to have their equipment as light as possible. Mm-hmm. That gives them the ability to less soil compaction, and they can reach further with their pieces of equipment if their equipment is lighter. So therefore, say you have something like a sprayer. If it's lighter, they have no real need for wear components, but they have a need to make that equipment as light as possible. That way they can reach more and cover more area every pass through the fields.
Okay, this is where I really want to understand it. So a client comes for you. It's the company building the sprayer that's actually coming to you, right?
That's correct. We work with mainly like OEMs, fabricators.
Let's talk about our Heavy Industry World Tour brought to you by Sabina Equipment. Find, market, and sell surplus and used equipment. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. Did you know cementitious binders can be responsible for up to 70% of the total GHG footprint of mine backfilling processes? Now you can replace up to 50% of the binder in your mine backfill operations with Graybond, Graymond's new low-carbon cementitious binder. This lime-based alternative binder maintains a 40 to 70% lower GHG footprint compared to typical cement and can adapt to varying mine conditions without compromising performance. Learn more about Graybond at graybond.com. Attention builders, we've got everything you need to know about the grit and grind of the construction world in one show. The Construction Show is where you can share your expert techniques and strategies to help keep the crew strong and construction sites secure. From foundational tips, industry trends, safety strategies to advanced equipment and machinery. Be part of the voice of construction. Book your episode and showcase your company to millions worldwide. Visit crownsman.com. Join us in the depths of the mining world, where global leaders and industry giants converge to shape the future of mining. From groundbreaking technologies, advanced machinery, revolutionary safety measures, to sustainable initiatives. This is the voice of mining. This is Mining Now. Showcase your company to millions worldwide. Book your episode now. Visit crownsman.com.
Okay, so they're saying, I need this sprayer. It's going to be out 30, 40 feet, let's say. This is what I want to build. And then do you say to them, these are the steel like, what is the actual process from the time they say what they're building to when they actually buy the steel?
So we will work with them and give them the options that we have for the different types of steels that we produce and help them to work with trying to pick the best steel for their application.
Right.
So we work together with the OEMs and the manufacturers to help them produce the best equipment that they can.
So if they're saying, no, I need this, how would I say it? If they need it to be, let's say they want it to be 15 or 5%. Let's go reasonable now. 5% lighter. Are they coming, they say, we have this design. Will this steel work? Are you getting into the actual engineering, or do they say this is the steel we need? Well, I know I'm getting really into the weeds here, but I think it's for companies who are thinking about reaching out, it's good to sort of understand what they...
Yeah, we do work with a lot of our OEM manufacturers on trying to help them to develop the best piece of equipment. So we do offer some engineering services. In other words, basically we have a group back in Sweden that we call our Knowledge Service Center, KSC. And what we will do is if they submit their drawings to us, we'll, of course, sign an NDA. And then we will take a look at their drawings and then make recommendations for the best steel to use for this application.
You are looking at the designs and saying, okay, this could work for that. Oh, okay. Yeah. Where is the industry at? Like, is it just always lighter, stronger? Like, what is that conversation like? It seems like it'd be a pretty ongoing...
It's always ongoing. I mean, nobody wants to jump from point A to point Z. Everybody wants to take steps in between. So they'll make incremental steps in strength and reducing the weight. But nobody wants to take that big jump and, reduce the weight 50% overnight. Yeah. So, they're going to work on reducing the weight, say 5-10% at a time. And if that works well, they don't have many failures, after a few years of seeing this work in the field, then they'll start looking at reducing the weight further.
So when you say structural steel, like the strengths, is that going to be, what are you touched on a couple, but can you give some more examples of where that steel would be applicable?
Can be used in any type of, whether it be like a trailer chassis, pretty much any type of chassis where you're going to have a piece of equipment that's rolling over the ground. So let's see, there could be a number of applications for strengths anywhere you need a structural piece of equipment, especially when it's mobile. So a lot of mobile equipment, that is made to run around out in the fields, we can help make that piece of equipment lighter with strength steel.
Okay, when you say the chassis themselves will be that strength steel.
Correct.
Yeah. Then I get, sorry to go into the weeds on this, but it's just I don't get a lot of opportunities to ask these kind of questions. So what about like on the OEMs, like all the other steel, like on the door and all that sort of stuff? What is that steel?
Well, a lot of times it's what we call mild steel. So it'll be like a 836 or a 50 KSI steel. 50
KSI. So, okay. I'm learning here. So the Hardox is like a 500 K.
Well, no, that's 500 Burnell. So that's the hardness.
Okay. No, I'm not learning.
So with strengths, one of our most popular grades in North America is strengths 110 XF. So it's 110 KSI.
Okay.
So that would be, like more than 2 times as strong as 50 KSI steel, grade 50. And so with that, we can reduce the thickness, say, anywhere from 30 to 40% over a mild steel like a grade 50.
Right. Okay. Because it's stronger.
It's stronger, correct.
Right.
The density is the same. So most all carbon steels have the same density.
Right.
So the only way to make a structure lighter is to go thinner. And to be able to handle the same stress load, the steel needs to be stronger.
Right. Okay. So let's go back to the door example. So on a door, you've got a 50. It's a K.
50 KSI.
50 KSI. Now let's move down into. Now you're saying on the chassis though, that would be a what?
Well, it really depends on the manufacturer. I mean, a lot of them could be just a normal 50 KSI steel. And some people will call that high-strength steel. But we come to them and say, we've got a real high-strength steel and something that's 100 or 110 KSI. And then we can reduce the thickness and still have very good fatigue.
So then you get that lighter, it's a lighter machine. Now, this is especially true in agriculture because they're always after
correct,
these big machines going across these open fields. It's lighter, faster, less wear. Okay, so the Hardox is the hardness, appropriately named. Strength is the strength of the steel. That's sort of how you divide up those two. Are there sort of guarantee across the board on both of those, or even the guarantee, does it change on what that is? Because you have a quite strong guarantee, if I remember right.
Yeah, the guarantees, for Hardox are slightly different because, that steel is based on hardness. Yeah. Where in strengths, the guarantee there is more or less the strength of the material and the toughness.
Right.
But we have a very good guarantee brochure for each Hardox and strengths that will list things like better thickness, better flatness tolerance. We actually have bending guarantees. So we have a minimum inner bending radius that we guarantee for our Hardox and strength steels. And so those better guarantees guarantee the customer that their workshop properties are going to be better, much more consistent than what they would normally see with a commercial grade of steel.
Is that what sort of separates Hardox out from their competitors? I mean, obviously there is competition in the industry and from all over the world. So where do you find that spot where you go, we're hard to beat here?
Really comes down to consistency and the guarantees. When you have a plate that's much more consistent, it's better flatness, better through thickness, and then when a customer's working with it, he's cutting it, he's forming it, he's bending it, and he's welding it, he's getting much more consistent operations in the shop. And when they get better consistency in the shop, their productivity increases.
Yeah.
So, I've been quoted by several customers that they see an increase of productivity anywhere from 10 to 15% in their workshop, just by using, say Hardox compared to a generic AR steel.
Have you ever had anybody go for the for the generic and then have to come back?
We've had that happen. Sometimes they get frustrated because Hardox is not necessarily the cheapest steel in the world.
Yeah.
But, they generally tend to come back because they tend to figure out, you pay a little bit more for the steel, but you get what you pay for. You get better consistency.
Well, especially in design and in any sort of manufacturing, if you lose quality on the product that you're trying to work with, the productivity drops. Then you've got downtime. Then you're trying to work. Then you've got problem-solving time. Then you probably get the R&D department involved to try to make a workaround. And all of a sudden, you're saying 15%. I bet you there's cases where it's been, 50% efficiency. I bet you there's been cases where they probably haven't even told you how much efficiency they lost.
Yeah, well, I mean, they got to have that little bit of edge. So, when they are talking to the salesperson about pricing, they're not going to be like, hey,
you're going to save us 40%. So you should be a little more
they don't
expensive.
Want to quote that number. They're just saying, it's a little better, but, it's not that much.
Well, so the limited access I have is I used to work in the siding and eaves trough business. That was my first company.
Okay.
So the difference of one manufacturer's aluminum to another's, you think it's the same. It is not the same.
No,
it is not the same. And when you get those efficiency issues happening, it's a disaster. It wouldn't be a heavy industry episode if you didn't talk about trying to get zero carbon, lower carbon, zero emissions. Um, your Hardox actually has doing some interesting work that I was confused by a little bit, to be honest. So thank goodness I'm here talking to you. What's going on in that space for you?
Well, actually, we've been working on developing two new. Well, it's not really new types of steels. It's basically new steel making technology. So
Okay.
ultimately, what we're doing is we're looking at producing steel with zero carbon emissions. So what this does is, we're looking at replacing blast furnaces in Sweden and replacing them with electric arc furnaces and using our hybrid uh, direct reduced iron in the electric arc furnace. So basically, it's fossil free emission steel.
So what's an electric arc?
Electric arc furnace is what we use to melt things like scrap metal.
Okay.
So the mill that I came from in Mobile, Alabama, we have electric arc furnace where we melt mainly scrap steel.
Okay.
And so through that refining process of melting the steel down, removing the impurities and adding the alloy elements that we need, and then producing the steel to meet a certain grade.
Yeah. So I'm sorry. I'll have to get you to walk through a little bit. So they're removing what component?
Well, ultimately, they're changing the type of melting that is happening.
Yeah.
So they're going from a blast furnace, which was something that's been used for well over 100 years, and they're replacing that with electric arc furnace.
So, Kate, again, I wish I just knew more, but that's part of the fun. I speak for the audience sometimes.
Yeah.
So when they say steel making coal, what is that? Do you mean the coal? That's actually used in the steel, though, or is that just being used to heat the steel?
Well, there's a couple of different things that we look at there. So, when you're melting steel, then you're using some carbon or coal to actually melt and reduce the steel itself, because with a blast furnace you're reducing iron ore. So iron ore is Fe2O3, and so ultimately what you're doing is you're kind of separating the iron from the oxygen, and you're wanting to melt the pure iron. And then so you use a lot of coal in that process of reducing the iron. So what we have now is we have what we call hybrid. So hybrid is the technology where they're reducing the iron with pure hydrogen instead of natural gas. And so they're converting iron ore into a substance called sponge iron that can be used in an electric arc furnace. And so the electric arc furnace will melt the hybrid iron and produce a steel. And from there, we can produce whatever our normal steel grades from this, iron that's produced from the hybrid technology.
So is this a product out into the market, or is this being developed?
It is out in the market. It's
okay.
On a smaller scale. So we're not ramped up full production. That will take a few years before we can get to that level. We're looking, say, by 2030, they would like to be, fully on board with going to fossil-free or emissions-free steel.
Where's the bottleneck on a process like this?
Well, for one, being able to produce enough hybrid iron to supply all the iron that would be needed. So that is still on a small scale production.
Is that kind of recycled typically then?
Well, that's not recycled. That's basically taking iron ore and reducing it to a usable substance, sponge iron, that we can use in the electric arc furnace. Now, the other route that we're doing is what we call SSAB 0. So the SSAB 0 is basically we're melting steel and producing steel with renewable energy.
Yeah.
So a cleaner energy. And so, therefore, there's no real carbon emissions from the energy production. And then the steel being produced has a lower emissions output for the steel that is being produced.
Is this something? I mean, this is not a small thing that you're saying, because this is a major challenge in the industry for years. The pollution from steel itself. Is this a scalable? Like in 50 years, could this be the way that steel is made and produced?
Oh yeah, I mean it's just a matter of time before more steel manufacturers start to look at producing steel in different terms, and with the SSAB zero, so basically it's just about renewable energy to power the furnaces and
Right.
the equipment we currently have. So
Right.
it's not a real big step
Right.
as in a whole new technology. It's just a matter of producing steel through melting scrap with renewable energy.
So you've kind of got two things going. The way that you're producing the steel, that that's what you're hoping to come out with. You've done it on a small scale. You're hoping to scale up, and then how
Correct.
you're actually powering your current facilities. So there's two things happening here.
That's correct.
Just to wrap up, anybody watching this show, again, who is the right person? Is it you've already mentioned some of them, but who are you sort of hoping to tap into within the agriculture sector specifically?
Most any fabrication shop that's dealing with agricultural equipment, because most say customers like John Deere, they produce large producer of ag equipment,
Yeah.
but they still buy components from a lot of other fabricators. So
Right.
there's several fabrication shops that build components for companies like John Deere.
Yeah.
So anybody that is producing parts for any other OEM or manufacturer, we work with all those types of shops.
Is it from small to large, or
Small to large.
Yeah, it doesn't matter to you.
It could be somebody who's buying 100 tons of steel a year, to some who are buying 2,000 or 3,000 tons of steel per year.
Okay. Thank you for doing the show. Thank you for being on twice. I hope the second time was as good as the first for you. No, I really do appreciate your time. I grew up around equipment, so I just grew up around steel and have never got to do an interview about it. So it was actually a pleasure for me. Thank you very much. I hope we do it again.
Okay. Thank you.
Thank you, Jimmy. And thank you, everybody, for watching. That is another episode of Agriculture Now. Go check out Hardox. Wow. You can connect. I've been doing a few interviews today. You can connect with Jimmy directly on LinkedIn. Thank you, everybody. We will see you. Oh, and make sure to subscribe. See you on the next episode of Agriculture Now.